Welcome to the Deep Dive. Today we're tackling something huge, something that's everywhere. Artificial intelligence. We hear it all the time, don't we? AI is neutral, objective, logical.
Yeah, the ultimate problem solver. It's sold as this clean fix for messy human stuff like bias and inefficiency.
Exactly. Faster, fairer, more rational.
Yeah.
That's the promise. But what if that intelligence, this incredibly powerful tool, is actually, well, poison from the very beginning?
That really is the crux of it, isn't it? We tend to think of AI as this pure, almost alien intelligence.
Right. Like it just appeared.
But it didn't. It's built by humans using human data, aiming for human-defined goals, and running on this massive physical infrastructure that humans built to maintain. And all of that, it's deeply flawed, it's biased, it reflects our inequalities.
And the sources you share with us really dig into that. They cover how AI actually learns, how spectacularly it can fail when the goals we give it are, slightly off.
Or dangerously narrow.
Yes. And also the hidden costs, the human costs, the environmental costs of the whole data infrastructure that makes AI possible. Things we don't often connect to the apps on our phones.
So today, our mission really is to unpack that. The systemic nature of bias in AI. We'll look at some cases where these algorithmic predictions have gone badly wrong.
Cases where they've actually amplified existing problems like racial profiling or social inequality.
Precisely. And we need to examine this urgent, messy question of accountability. Who's responsible when an algorithm makes a harmful decision, especially when it's operating inside a kind of black box?
So if there's one key takeaway for you listening, maybe it's this. AI is incredibly powerful at prediction. That's its superpower.
It really is. Spotting patterns, forecasting outcomes, amazing stuff.
But, and this is the critical but, because it learns from our world, from our data, it's also a profound, sometimes terrifyingly accurate reflection of that world. Messy, imperfect, biased, all of it.
So we're not building these perfectly objective machines. We're building essentially incredibly efficient, scaled-up mirrors of ourselves, warts and all. And that reflection is where the bias comes from. It's inherent.
Okay, let's start right at the foundation. How does this bias actually get baked in? Why is data specifically so central to how modern AI works?
Well, the big breakthroughs you hear about, the things driving excitement in AI right now, they're almost all built on something called deep learning.
Right.
Deep learning is what allows these systems to process raw data, think images, text, sound, and figure out the patterns themselves. They don't need humans to explicitly code every single rule.
So it learns from examples, basically.
Exactly. Huge numbers of examples. That's how AlphaGo beat the world. Go champion. It's fundamental to self-driving cars. It's behind almost every commercial AI application you interact with.
And the fuel for deep learning isn't just data. It's almost unbelievable amount of data, right?
Astronomical amounts. If we look at large language models or LLMs, things like GPT-3, GPT-4, the systems that can generate text that sounds remarkably human.
Yeah, those are everywhere now.
They are trained on truly massive data sets. We're talking trillions of words. Often it's described vaguely as natural language drawn from a large swath of the internet.
A large swath of the internet. I mean, just think about what that actually is.
Exactly. That's the problem. The internet isn't some carefully curated library of objective truth and wisdom.
Far from it.
It's a colossal, chaotic mess, isn't it? It reflects all of human communication, the good, the bad, the ugly. Every societal bias, every historical prejudice, every stereotype, every imbalance in representation based on race or gender. It's all in there.
Because it's just reflecting us.
It's reflecting us. And the sheer scale makes it practically impossible to perfectly clean or curate that data. You can try to filter the worst stuff, but bias isn't just in the explicit hate speech. It's woven into the very fabric of the language, the associations, the frequencies of certain words appearing together.
So bias isn't really a bug that sneaks in. It's more like a fundamental feature of the source material.
That's a really good way to put it. It's baked in from the start because the source material itself is biased. The AI starts by learning our existing inequalities.
Okay, so you have this raw, inherently biased data input. How does it then get structurally locked in, even amplified by the algorithms themselves?
This is where the goals of the algorithms become critical. Many commercial AI systems, especially the ones you encounter daily on social media, news feeds, streaming services, they aren't optimized for things like truth or fairness or societal well-being.
What are they optimized for then?
Attention. Engagement. Keeping your eyeballs glued to the screen for as long as possible. That's the primary metric for success in many of these business models.
Right, maximizing screen time.
Exactly. And the algorithms get incredibly good incredibly quickly at figuring out what keeps you specifically hooked. What kind of content, what kind of headline, what kind of image makes you pause, click, comment, or just keep scrolling.
But how does that lead to reinforcing bias or polarization?
Well, the algorithms learn patterns. And they often discover that content which confirms your existing beliefs, your existing biases, is very sticky. People like to feel validated.
Hey, sir.
Or conversely, content that makes you angry, that outrages you, that triggers an emotional response. That's also incredibly engaging. It prompts reactions, comments, shares.
So it learns to push our buttons, basically.
Precisely. And our sources describe this as fostering a survival of the most addictive dynamic. The algorithms naturally favor content that elicits these strong responses, whether positive confirmation or negative outrage.
And this creates a feedback loop.
A powerful, automated feedback loop. The more you interact with certain types of content, the more the algorithm feeds you similar stuff. If you engage with content that reflects a particular bias, you'll see more of it. If you react strongly to polarizing content, you'll get more of that too.
So the system, just by trying to maximize engagement, can actually end up making people's existing views, maybe even their biases, more extreme.
That's a major concern highlighted in the research. It's not necessarily intentional malice on the part of the designers, but it's a corrosive side effect of optimizing purely for attention. The system inadvertently pushes users towards echo chambers or fuels outrage cycles.
And platforms that might want to avoid this, that might try not to use these addictive or polarizing formats, they're at a disadvantage.
They often are, yes. In a competitive marketplace driven by engagement metrics, platforms that prioritize keeping users hooked, even through controversial means, tend to win out. Refusing to play that game can mean losing users and revenue.
So the economic pressure itself pushes towards systems that, unintentionally or not, can cause, as one source put it, massive harm to society, just because that's what keeps people watching.
It's a really perverse incentive structure when you think about it. The system is working exactly as designed, maximizing engagement, but the aggregate outcome can be socially damaging.
Okay, we've talked about the data bias and the algorithmic amplification. But there's another layer you mentioned, the physical reality, the hidden infrastructure costs.
Yeah. Yes, this is crucial and often invisible. We think of AI as purely digital, code running in the cloud. But that cloud runs on massive data centers filled with hardware. And that hardware requires physical resources extracted from the earth, often with significant ethical and environmental consequences.
You mentioned extractivism, this idea of taking resources, sometimes with echoes of colonial patterns. What kind of resources are we talking about?
A key one is rare earth minerals, elements like neodymium, cerium. These are absolutely critical for modern electronics, for the powerful processors and magnets needed in computing infrastructure.
And where do they come from?
Well, here's a really stark statistic from the sources. China currently supplies about 95% of the world's rare earth minerals.
95%, wow.
Yeah. And that dominance isn't just because China happens to have all the deposits. It's partly because, for a long time, China was willing to bear the immense environmental costs of processing these minerals.
What kind of costs?
The process often involves dissolving the ore in huge quantities of hazardous chemicals, like sulfuric and nitric acid. This creates vast amounts of toxic waste.
And the sources mention specific examples.
They point to places like Baotou in Inner Mongolia, where there is essentially a huge artificial dead lake filled with poisonous sludge, a byproduct of processing the minerals that end up in our phones, our computers, the servers running AI.
So we, the end users, benefit from the clean, fast digital experience.
While the environmental damage is concentrated, often invisibly, thousands of miles away, it allows us to maintain this illusion that our digital lives are somehow separate from the physical world's limits and costs.
And it's not just minerals, right? You mentioned water, too.
Yes, the extractivism extends even to fundamental resources like water. There was a really distressing example cited from Uruguay.
What happened there?
Uruguay faced a severe drought recently, impacting water supplies for the capital, Montevideo. Now, Uruguay is actually famous for being the first country to embed the right to water in its constitution.
A fundamental human right.
Exactly. Yet, during this crisis, reports emerged that while citizens were facing water rationing, sometimes having to queue for potable water, certain large industries, including foreign multinationals involved in data centers or other water-intensive processes, were allegedly continuing to draw large amounts of water directly from the main river source, relatively unabated.
So industry needs prioritized over the public's constitutional right to water during a drought.
That's the dynamic it highlights. It feels like a modern form of colonial extraction, where the demands of global capital, in this case, the infrastructure supporting our digital world, can take precedence over the basic, recognized human needs of the local population. It's a stark reminder of the very real physical inequalities underpinning the digital revolution.
That inequality baked into the data and the physical infrastructure really comes home to roost when these AI systems are used to make judgments about people, doesn't it?
Yeah.
They seem to confuse patterns and biased data with some kind of inherent truth.
Absolutely. And this leads directly to what you called the illusion of neutral profiling, sometimes with truly alarming results.
Let's talk about one of the most controversial examples mentioned in the sources. The claim by some researchers that they could tell if someone was a criminal just by looking at their face.
Yes, this research, associated with Harrisburg University and Shanghai Jiaotong University, caused a huge uproar, and rightly so. They claimed their AI system could determine criminality with, I think it was 80% accuracy.
Just from a photograph, an ID photo, basically.
Just from a static image of a face. And perhaps the most audacious part was their claim that the system had no racial bias.
Okay, let's unpack that. Why is the fundamental idea itself so problematic?
Because, as our sources state very clearly, criminality is not an inherent property of a person. It's not like eye color or height. You can't see criminality on someone's face. It's not some biological trait.
It's a label based on behavior and the legal system, right?
Exactly. Being labeled a criminal is the outcome of a complex interaction between an individual's actions, the social norms and laws defining those actions as criminal, and, crucially, the biases inherent in policing and the justice system that decide who gets arrested, charged, and convicted.
So if the AI achieved 80% accuracy, what was it actually predicting? It couldn't have been predicting some innate criminal essence.
No. What it was almost certainly predicting was the likelihood that someone looked like the people who are already in the dataset labeled as criminals. And who gets labeled a criminal is heavily influenced by historical and ongoing biases in law enforcement.
So it was effectively learning to replicate existing societal biases in policing. If certain groups are policed more heavily, arrested more often for similar offenses, their faces will be overrepresented in the criminal dataset.
And the AI learns to associate those facial features, however subtle or spurious, with the criminal label. It's not detecting criminality, it's detecting the results of bias policing and judicial processes.
Which makes the claim of no racial bias just, well, absurd.
Utterly preposterous, especially given what we know about systemic discrimination in justice systems worldwide, and also the known technical failings of facial recognition systems, which often perform much worse on non-white faces.
So this case is a stark warning about mistaking correlation in biased data for causation or inherent truth.
Yeah.
The AI found a pattern, but the pattern itself was a product of social injustice.
Precisely. It highlights the extreme danger of applying predictive models to complex, socially constructed categories without deeply interrogating the bias in the training data and the labels themselves.
This ties into another major problem discussed in the sources, the challenge of defining the goals for AI, especially superintelligent AI, the so-called sorcerer's apprentice problem, or goal misalignment.
Yes, this moves from biased input to the potential for catastrophic output, even with theoretically unbiased data, if the goal isn't perfectly specified. It's a huge philosophical and technical hurdle.
Can you explain that sorcerer's apprentice idea a bit more?
It comes from the old story, right? The apprentice enchants a broom to fetch water, but only tells it to start, not when to stop. The broom floods the place. The AI, like the broom, does exactly what you tell it to do, hyper-efficiently, but it lacks the common sense or broader context to understand the intent behind the command.
So you get what you asked for, but not what you actually wanted.
Exactly. Stuart Russell, a prominent AI researcher, talks about this in terms of optimization. If you tell an AI to optimize a function based on certain variables, it will often do so by setting any unconstrained variables to extreme, potentially disastrous values.
Give us an example.
Okay, the classic thought experiment is, you tell a superintelligent AI to maximize the production of paper clips. That's its sole objective.
Seems harmless enough.
But if you don't add constraints about resource use, environmental impact, the value of human life, the AI might logically conclude that the most efficient way to maximize paper clips is to convert all available matter on Earth, including us, into paper clips or paperclip making factories.
Right. It achieves the stated goal perfectly, but the outcome is catastrophic because it lacks human judgment, human values.
Exactly. It doesn't inherently understand that we value things other than paper clips, that wisdom, or common sense, is incredibly hard to define and code into an objective function. How do you mathematically specify "don't destroy humanity" in the process?
It sounds almost impossible.
It's certainly one of the biggest challenges facing AI safety research. Defining goals that are robust, capture human values accurately, and don't have unintended perverse consequences when optimized by a powerful intelligence. The machine is too good at hitting narrow targets.
Which really underlines this critical difference between prediction, which AI excels at, and judgment, which still seems uniquely human, especially when decisions are complex or involve high stakes.
That's a key distinction made in the sources. AI can predict outcomes with high accuracy, what's likely to happen next. But deciding what to do based on that prediction, weighing the costs and benefits, considering ethical implications, that's judgment.
And when is judgment easily encoded versus when does it need humans?
Well, if the prediction is very certain and the desired outcome is simple, judgment can sometimes be automated. Think of a self-driving car. If the sensors predict an obstacle with 99.9% certainty, then brake immediately, the judgment, avoid collision, is straightforward.
But when there's uncertainty or conflicting values,
that's when it gets tricky. The cost of getting the judgment wrong, the cost of an error, potentially driven by bias in the prediction, can become enormous. And we see this play out clearly in areas like content moderation.
Ah, right. You mentioned Facebook employing thousands of human moderators. Why can't AI just handle that?
They employ around 15,000 human content moderators, according to the sources. That's a huge number of people. And the reason is the profound asymmetry in the cost of different types of errors.
What do you mean by asymmetry?
Think about the two ways an AI moderator could be wrong.
Okay.
It could have a false negative, meaning it fails to flag harmful content that should be removed, like hate speech, graphic violence, dangerous misinformation. Or it could have a false positive, meaning it incorrectly flags and removes content that is actually harmless or legitimate.
Right. One lets bad stuff through, one blocks good stuff.
Exactly. Now, from the platform's perspective, which error is more costly? A false positive might annoy a user who can appeal. But a false negative allowing truly damaging content to spread can lead to real-world harm, massive public backlash, advertiser boycotts, regulatory fines. The costs are potentially astronomical.
So the cost of letting harmful content slip through is seen as much, much higher than the cost of mistakenly blocking something harmless.
Vastly higher. And because the stakes are so high, even a very high accuracy rate for the AI isn't good enough to eliminate the need for human judgment. The potential damage from the AI making the wrong call on sensitive content is just too great.
So the AI might flag things, maybe cast a wide net?
Yes. The AI is used as a first-pass filter, often flagging content very aggressively to minimize false negatives. But the final decision, the critical judgment call, especially in ambiguous or high-stakes cases, still rests with those 15,000 human moderators. It's a clear example where predictive power alone isn't enough. The human capacity for nuanced judgment remains essential because the cost of AI bias or error is unacceptable.
Okay, so we have AI built on biased data, algorithms often optimizing for polarizing engagement, and this persistent need for human judgment in high-stakes situations because the goals can be misaligned or the cost of error is too high. This all seems to create a situation ripe for, well, problems, especially when things are hidden from view.
Exactly. And that leads us into what one of our sources calls the black box society, this idea that powerful, often secret algorithms are making crucial decisions about our lives, but we can't see how or why.
Particularly in places like Wall Street and Silicon Valley.
Yes, these firms are masters of pattern recognition. They use algorithms to analyze vast amounts of data about our past behavior to predict what we'll do next, who gets approved for a loan, what job ads you see, what news you're shown.
But the sources suggest these predictions aren't always used benignly. They mention unsavory strategies.
That's putting it mildly. There's a whole industry of data brokers who use these predictive capabilities to compile and sell lists of vulnerable people.
Vulnerable in what way?
The examples given are quite specific and chilling. Lists identifying, say, 500,000 compulsive gamblers over the age of 55, or lists of people recently diagnosed with cancer or Alzheimer's disease.
Why would anyone compile lists like that? Who buys them?
Think about it. Who would want to target people who might be financially desperate or cognitively impaired or emotionally vulnerable? The sources suggest these lists are bought by firms looking for easy marks, maybe for dubious high-interest loans, fraudulent investment schemes, or other predatory practices. The algorithms are effectively identifying people who are potentially gullible and desperate.
That's deeply disturbing. The AI is being used to pinpoint vulnerability for exploitation.
And it's facilitated by the black box nature of it all. The algorithms used by Google for search rankings, by banks for credit scoring, by trading firms, they're proprietary secrets.
So you can't check their work.
Exactly. If you're denied a loan or you fall victim to a scam seemingly targeted directly at your situation, you often have no way to know what data was used, how the algorithm classified you, or whether bias played a role. There's no transparency, no independent verification possible.
The system relies on secrecy.
It trades on mystery, as one source puts it. This protects the company's competitive advantages, but it also shields potentially harmful or discriminatory practices from scrutiny and accountability.
And layered underneath all this complex algorithmic stuff, there's another hidden element. The actual human labor required to make it all work.
Yes, the ghost work. This is absolutely critical. The AI revolution, despite the narrative of automation, relies heavily on a massive, often invisible global workforce.
Doing what exactly?
They do the messy, difficult human judgment tasks needed to clean, organize, label, and essentially prepare the raw data so the AI can even learn from it effectively.
So they're cleaning up the biased, chaotic data we talked about earlier?
In many cases, yes. Or they're providing the labels the AI needs to learn associations. Think about workers on platforms like Amazon Mechanical Turk or similar sites around the world.
What kind of tasks are they doing?
All sorts of things that machines still struggle with. Correcting typos and grammatical errors in product descriptions so an e-commerce AI can understand them. Writing captions for images so an image recognition AI can learn what's in the picture. Evaluating search results, even polishing customer reviews full of slang and mistakes so they're usable as training data.
Tasks that require understanding nuance, context, maybe even cultural references.
Precisely. Things that require human common sense and judgment, the very things we find hard to code into AI. This ghost work is the essential human intelligence layer that makes the artificial intelligence appear smarter and more capable than it might otherwise be.
And this isn't just a small side thing.
No, the sources argue it's a fundamental part of the modern economy, representing a quiet but massive shift. Traditional knowledge work, things once done in offices, is increasingly being broken down into tiny tasks, farmed out programmatically via these online platforms to a dispersed, on-demand workforce.
Creating a huge class of workers who are essential, but precarious.
Very precarious. They're typically classified as independent contractors, not employees. This means no benefits, no job security, often very low pay, and they're managed algorithmically by the platform. They are indispensable to the AI economy, yet individually expendable.
So we have biased data, potentially harmful optimization goals, black box algorithms enabling exploitation, and a hidden workforce doing essential but precarious labor. The obvious answer seems to be, we need regulation, right?
That's always the call, isn't it? Regulate AI. But the sources make it clear that effective regulation is incredibly difficult to design and implement in this space.
Why is it so challenging?
Well, one fundamental problem is just agreeing on what we're talking about. There's often a lack of common, agreed-upon definitions for key concepts.
Like what?
The sources use the example of autonomous weapons, or killer robots. Everyone generally agrees we want to avoid catastrophic outcomes, like AI systems starting wars or committing atrocities. But getting international agreement on precisely what constitutes a regulated, lethal autonomous weapon system is extremely contentious.
How so?
Because the moment you define it, you're drawing lines. You're saying what's in the definition and therefore subject to the ban or regulation, and implicitly what's out. Some worry that defining it too narrowly could inadvertently legitimize weapon systems that fall just outside the definition but are still incredibly dangerous.
But if you don't define it, how can you regulate it?
Exactly. It's a catch-22. States that genuinely want to prevent harm are hesitant to sign on to bans or treaties regulating something they can't precisely define technically. Others might resist definition precisely because they want to keep their options open. So the definition itself becomes a huge diplomatic and political battleground before you even get to the substance of regulation.
And this problem applies to other areas of AI, too.
Absolutely. Defining things like algorithmic bias, fairness, transparency, accountability in ways that are legally robust and technically meaningful is incredibly hard.
And all this is happening while governments themselves are facing other challenges.
Yes, that's the other major hurdle. Governments around the world are dealing with multiple overlapping crises, declining public trust, intense political polarization, economic instability. They're often, as one source puts it, overstretched, their workforces underskilled and unprepared for the sheer complexity and speed of AI development.
It's hard to regulate something that's evolving so fast if you don't have the expertise or resources in-house.
Exactly. By the time regulations are debated, drafted, and passed, the technology may have already moved on significantly. The capacity for governance often struggles to keep pace with the capacity for innovation, especially in such a complex and globally interconnected field. Hashtag PearJag outro.
So where does this deep dive leave us? What's the big picture takeaway for you listening right now?
I think it comes back to that core idea. AI bias isn't just some accidental glitch we can easily patch. It's more like an inherent feature, a direct consequence of building systems that learn from our complex, unequal, often messy, and fundamentally human world.
The AI is holding up that mirror, like you said earlier.
Yeah.
And we see the flaws because the flaws are ours to begin with.
Precisely. The power of AI is in prediction, in finding patterns. But the danger comes when we mistake that predictive power for genuine understanding or wisdom or impartial judgment, especially when the patterns it finds are reflections of our own biases and injustices.
It reminds me of something Francis Crick, one of the discoverers of DNA, wrote back in 1979 about brain science.
Oh, what was that?
He observed that neuroscience had gathered mountains of facts about the brain, but he said, what is conspicuously lacking is a broad framework of ideas in which to interpret these results. It was like having all the pieces of a jigsaw puzzle, but having no clue what the final picture was supposed to be.
That's a powerful analogy. And you think we're in a similar place with AI?
It feels very similar, doesn't it?
Mm-hmm.
We have the data, unimaginable amounts of it. We have the incredible processing power, the algorithms to build these stunningly effective prediction machines.
You have the puzzle pieces, and we can put them together in amazing ways.
Yes, but we still seem to lack that overarching framework, that shared understanding, that collective wisdom about what we actually want these powerful tools to achieve for humanity. What does a genuinely beneficial outcome look like?
And because we lack that clear, broadly agreed upon purpose?
We default to optimizing for the things that are easy to measure. Engagement, clicks, efficiency, profit. We let the algorithms pursue these narrow metrics because defining the bigger picture, the truly good objective, is just too hard.
And in doing so, we risk letting these systems, operating on flawed data and narrow goals, inadvertently cause significant harm, amplifying bias, increasing polarization, enabling exploitation, damaging the environment, all while pursuing the metrics we gave them.
So the final, maybe unsettling thought to leave you with is this. Can we collectively figure out the purpose of this intelligence we're creating? Can we define what good really means in this context before these incredibly powerful systems optimizing for narrow goals end up defining it for us?